Welcome back. In the last video, we covered a whole bunch in creating our first PyTorch model that inherits from nn.module. We talked about object-oriented programming and how a lot of PyTorch uses object-oriented programming. I can't say that. I might just say OOP for now. What I've done since the last video though is I've added two resources here for gradient descent and backpropagation. These are two of my favorite videos on YouTube by the channel 3 Blue 1 Brown. So this is on gradient descent. I would highly recommend watching this entire series, by the way. So that's your extra curriculum for this video in particular and for this course overall, is to go through these two videos. Even if you're not sure entirely what's happening, you will gain an intuition for the code that we're going to be writing with PyTorch. So just keep that in mind as we go forward. A lot of what PyTorch is doing behind the scenes for us is taking care of these two algorithms for us. And we also created two parameters here in our model, where we've instantiated them as random values. So one parameter for each of the ones that we use, the weight and bias, for our data set. And now I want you to keep in mind that we're working with a simple data set here. So we've created our known parameters. But in a data set that you haven't created by yourself, you've maybe gathered that from the internet, such as images, you won't be necessarily defining these parameters. Instead, another module from NN will define the parameters for you and will work out what those parameters should end up being. But since we're working with a simple data set, we can define our two parameters that we're trying to estimate. This is a key point here, is that our model is going to start with random values. That's the annotation I've added here. Start with a random weight value using torch random. And then we've told it that it can update via gradient descent. So PyTorch is going to track the gradients of this parameter for us. And then we've told it that the D type we want is float32. We don't necessarily need these two set explicitly, because a lot of the time the default in PyTorch is to set these two, requires grad equals true and D type equals torch.float. It does that for us behind the scenes. But just to keep things as fundamental and as straightforward as possible, we've set all of this explicitly. So let's jump into the keynote. I'd just like to explain what's going on one more time in a visual sense. So here's the exact code that we've just written. I've just copied it from here and I've just made it a little bit more colorful. But here's what's going on. So when you build a model in PyTorch, it subclasses the nn.module class. This contains all the building blocks for neural networks. So our class of model subclasses nn.module. Now, inside the constructor, we initialize the model parameters. Now, as we'll see later on with bigger models, we won't necessarily always explicitly create the weights and biases. We might initialize whole layers. Now, this is a concept we haven't touched on yet, but we might initialize a list of layers or whatever we need. So basically what happens in here is that we create whatever variables that we need for our model to use. And so these could be different layers from torch.nn, single parameters, which is what we've done in our case, hard-coded values, or even functions. Now we've explicitly set requires grad equals true for our model parameters. So this in turn means that PyTorch behind the scenes will track all of the gradients for these parameters here for use with torch.autograd. So torch.autograd module of PyTorch is what implements gradient descent. Now a lot of this will happen behind the scenes for when we write our PyTorch training code. So if you'd like to know what's happening behind the scenes, I'd highly recommend you checking out these two videos, hence is why I've linked them here. Oh, and for many PyTorch.nn modules, requires grad is true is set by default. Finally, we've got a forward method. Now, any subclass of nn.module, which is what we've done, requires a forward method. Now we can see this in the documentation. If we go torch.nn.module, click on module, do we have forward? Yeah, there we go. So forward, we've got a lot of things built into nn.module. So you see here, this is a subclass of nn.module, and then we have forward. So forward is what defines the computation performed at every call. So if we were to call linear regression model and put some data through it, the forward method is the operation that this model does. And in our case, our forward method is the linear regression function. So keep this in mind. Any subclass of nn.module needs to override the forward method. So you need to define a forward method if you're going to subclass nn.module. We'll see this very hands-on, but for now, I believe that's enough coverage of what we've done. If you have any questions, remember, you can ask it in the discussions. We've got a fair bit going on here, but I think we've broken it down a fair bit. The next step is for us to, I know I mentioned this in a previous video, is to cover some PyTorch model building essentials, but we're going to cover a few more of them. We've seen some already, but the next way to really start to understand what's going on is to check the contents of our model, train one, and make some predictions with it. So let's get hands-on with that in the next few videos. I'll see you there.